There are only 3 properties of logs, but it's the use of them in conjunction with each other that gets difficult as we move through. So I've got you a little graphic organizer here. Did everybody get one? It's up to you. If you want to use it, use it. If you don't, don't. I'm not taking this back up, Will. Hush. This is just for you, to have something to keep everything straight with. Look at the first one. First one is a basic log. Anytime you have this base is the same as the argument there, it equals 1 every single time. And the reason it equals 1 is whatever this exponent is right here is what it's going to equal. So if I had log base, I don't know, 5 of 5 to the third, what would that equal? Nope, not this time. 3. It equals that exponent. Because remember what logs do. 5 to the what power would give you 5 to the third. Well, the what would be 3 there. Okay, so that's a basic property that, for whatever reason, it tends to makes it stumble a little bit, and I don't know why. But if the base and that number are the same, then it just equals 1. If there's an exponent on that number, then it just equals the exponent. Now, the second one there goes kind of hand in hand with this. It's log base b of 1. What is the only way? If it's 0. That's exactly right. If it's 0.
Sorry, I was so very lost.
Okay. So if you look at the examples, guys, Grayson, this is serious. Come on. If you look at the examples there on the right-hand side, the first one says the log base 14 of 14. What does that equal? 1. How about the log base 3 of 1? 0. The only way to get 1 when you raise something to an exponent is if that exponent is 0 itself. Because, oh, sorry. I can't imagine what I'm distracted about over here. All right, let's go to the good stuff. Actually, let's jump down to the change of base on the bottom. Let's do that last one. I'm going to go out of order just a little bit here and then hit the 3 big rules. The 3 big rules are the product rule, quotient rule, and power rule, but you've got, these are not really properties, they're just things that happen. I wanted to show you that one, the top one and the bottom one, then I'll talk about the 3 rules we use to expand and condense. Okay, now, change of base down at the very, very bottom. So skip down to the bottom. Remember how you all asked me, whenever we did logs, how you could put it in your calculator? And I said your calculator only does a base of what? 10, right? Well, so that's not the teetotal truth. It does. You just hit log, it's a base of 10. But you can write any log as a base of 10, okay? So that you could put it in your calculator. And what I mean by that is if you have the log base b of a, and I needed to write that with a base of 10, I could change this to log. Remember, if I don't put a base, it's a 10, right? Log of a divided by log of b. So it's log of the argument divided by log of the base. And this works no matter what the base is. I could change it to anything. I just always change it to 10 because that's what my calculator works in, right? So if I had something that I couldn't have, well, let's do one that we know first. Let's do log base 2 of 8. That should give me what? This is log base 2 of 8. 3, right? 2 times 2 times 2. Take out your calculator, though.
Oh, yeah, let me take that out. Oh.
That's the implied base. It's not written there, but I know it's a base of 10.
Yeah.
10.
So what's the log? What's the log to 8?
It should be 3, right? Because 2 to the what power gives you 8. Okay. So take out your calculator. Grayson, I am facing to put you in the hallway. Take out your calculator and
Yeah, we like Mike Tyson.
Yeah. Oh! What's wrong? Just a second, I'm gonna show you. All right. I should get 3 for this one, right? Take out your calculator and hit the log button and do log 8 divided by log 2 and tell me what you get.
1.4244.
Divided by log what?
You should get 3. Yeah, make sure that your parentheses here in. I want to make sure everybody can do this on your calculator before we move on, okay? So if I have something like, look over to the right there, if I have the log base 7 of 32, that's not one that I can just do in my head. Because you're not closing. Listen what I'm saying. Close the parentheses. All right. So, log base 7 of 32, do that on your calculator, because that's not one that I just know the answer to and I can check. So log 32 divided by what? Log of 7. What do you get? I need to know right now if you do not get this on your calculator. Can everybody get this on your calculator? Yes. All right. Listen, Grayson, listen.
67.
All right.
Dang it. How did I do it wrong? No, I got 0.56.
You put 7 first. All right, let's run through the rules. Rule number 1. Remember, this is on you. Logs are what? Exponents, right? Logs are exponents. So anytime you see a log, you automatically know that it's equaling an exponent. So that's going to make it a little bit easier for you to understand these properties. If you remember, they're actually exponents. So properties of exponents kind of coincide with these properties. So the first one is the product rule. So I've got this log with a base of b, and it's called product rule because I'm multiplying in these parentheses, okay? If you are multiplying inside the parentheses, then the product rule says that I can split these up and do log base b of m plus log base b of 10. Now, if you think back to your properties of exponents, when you're multiplying with the same base, you add the exponents, right? So when I'm multiplying here, I add the logs together to split them up. Now, when I move from left to right, this is called expanding when I move that way, okay? So I might give you an expression and I say expand the following logarithm. That's where you're making it bigger, right? I'm making it have more pieces. But if I take it from the right to the left, that's what we call condensing. So you'll have to be able to go backwards and forwards with this property. So you got 2 examples over on the right. The first one says to condense. And it is log. Now here's I should put a note here. These bases have to be the same for this to work. Oh. You don't know how to do it because I haven't taught it to you yet. I'm going to do an example. Don't call people dummies. That's not nice. That's not, definitely not nice.
We're going. That's the work. Acoustic. Lincoln. Acoustic Lincoln.
Notice on this example that my bases are the same. Yes. Say yes because they are.
No, you're on the second.
And it says to add them together. And if I add with the same base, that implies what? I got to multiply if I put them together. Right? Because this time I'm condensing, so I'm going from right to left. So this would be log base 5 of 40.
Was it the answer?
Yes. So I have something to do this if I need to.
Okay, well, that's not cool.
Well, you're not cool, so.
How
All right.
do we know which one it is?
See where it says condense?
No, like, how do we know, like, the next one, how do we know it's like 7, how do you know?
You really don't. You don't know. You just have, most of the time they're going to be variables, not numbers. I'll show you.
How do you know the multiply 9 and 7?
All right, so look at the next one. This is log base 2 of 63, and it says to, yes. And it says to expand them. So your expansion might look different than my expansion for this one. Because what multiplies to give you 63? 9 and 7. So I could say log base 2 of 9 plus log base 2 of 7. Does anything else multiply to give you? I could also say this is the same thing as log base 2 of 3 plus log base 2 of 21. Right? I could also say log base 2 of 2 plus log base 2 of 31. No, just kidding.
No.
Shut up, Stacy.
31.5.
Oh.
Before I called the conflict.
All right. I can't believe I just did that. What in the world? Okay.
I can't believe it either.
What if? Let's put a little. Gosh, Grayson. Let's put a little example on here with some variables.
Wait.
Right? So now if I have x times y, there's only one way I can expand this and split it up. Log, that's exactly right. I just made another one. I said, let's do one with variables just to show you what happens. Okay. Pretty simple. Everybody always says this. We run through log properties and everybody goes, these are so easy. This is so simple. Whenever we put everything together.
This is not so
Multiple times.
Multiple times?
Right. Stop being aggravated.
I'm not being aggravated.
Right.
I'll chill.
All right, let's look at property number 2. Read it, Grayson.
2.
What's property number 2?
Quotient.
Quotient rule. What does quotient mean?
Log B posting M over N. Alright, you ready?
I'm ready.
Log B, parentheses, M over N, parentheses. I'm not feeling it. You don't know how to do it. Oh no. Oh crap. Are you smarter than the 5th grader?
If I am dividing, I always remember this because the division sign here looks like a subtraction sign to me. But if I am dividing, then that means I subtract. Same thing, right? If I have exponents, if I have x to the fifth over x to the second, I subtract the exponents. Logs are exponents, so I subtract the logs when I do this. Do notice that I have to, on this one, I have to write the log both times. Don't not write the log. Make sure you write it both times. When you expand, every time you expand, you give everybody a log. Now, the example there, again, oh, I should write this. This is expanding when you move this way. Condensing when you move this way.
Well, that's kind of what we just did.
Right. So, read the example, Grayson.
Log 484 minus
Read it right. Log base 4 of 84.
Base 4 of 84 minus log 412. I mean, log base 4 of 12.
There you go. So if I condense these, condensing means I end up with log written only one time.
It's
Okay?
log 84 over 12.
That's right. So I get log base. Good. 4. Yes, you can. 84 over 12.
Yeah, but this still.
Now it's condensed.
Oh.
If I need to expand, the base here is 10, right? So the question is, how can I write, if I'm talking about the quotient rule, how can I write 9 as a quotient of 10? In other words, 9 equals what divided by what? 3 and 1.
3 and 3.
What you got to write it as a division problem, though. Not multi. 27 divided by 3 would work. Right? Do you see what we're doing here? So maybe I could write this if I want to expand it as log of 27 minus log of 3. Now the last one. He's not asleep. What's the third one? What's the third one? Power rule. Everybody loves the power rule one. It's the easiest. Power rule. What happens with our exponents when you raise a power to a power? You multiply. So I take this exponent, I bring it around to the front and multiply. This is expanding. This is condensed. As always. As per usual.
That was a good one.
Thank you. Grayson. How might I condense this one?
2 times log base 3 8.
Condense it.
Well, let's see. The 8 goes back there. So
Which
the 2 is the exponent. 3 stays a 3. No, the 8's the exponent. Oh, yeah, you're right, David. Yeah, I don't know.
What is 8 to the second power? Expand that one.
Yeah, x minus 1 from the front.
Put it in parentheses because the whole thing's being multiplied.
Okay.
All right, put that somewhere where you can reference it, and let's do some examples all together.
Okay, so
This is when it gets fun.
stop. That's not how you could have talked about your love. Okay. Correlation is butt. Or I eat his butt.
Yeah. Now, I'm going to tell you, there's not an order to do these in other than normal order of operations. Shut up. If I'm doing this, that means be quiet.
Yeah, that means I'm recording it. Hey, if his girlfriend was in here, if you make it this or go to
I'm going to just get one of y'all to kick him.
Okay. Like that. I can't. Yeah, you do it. You do it. I'm not saying I'm doing this stuff. Yeah, I think you couldn't do it better. I know he couldn't do it better. I mean, you also had less target. No, that was even the medical staff do the job. Oh,
Did you, sorry, did you finish? Condense. Condense that expression. Go.
I don't even know which one that's it. No, oh, you got to do multiple things.
I'm hearing good, huh? It is. Good job, Finley. Oh, but it's so easy. Isn't that what you said? It's so easy. I don't even need to pay attention because you said, what'd you do, Finley? Isn't that what you said when you put your head down? It's so easy. All right. So before I can combine them with subtraction, I need to handle this exponent here coming around. So I get log of 36 minus log of 9. And then how do I condense with subtraction? I divide. What is 36 divided by 9? Easy peasy. This one's for you, Will. You ready?
Give me like
36 divided by 9.
Hey, you need to pay attention.
I will give you a hint on this one. Make sure you move left to right. Will.
I give up. It's going to be log 3.
Hmm? Tell me what you're doing first.
Log base 328 y. What'd you get? Log base 328. That's what I got. Yeah.
What is 49 to the 1/2? 7. Square. Look at y'all. I'm impressed. Look. Okay, where are you confused? So I always go through when I'm condensing. To me, condensing is easier than expanding. I do all my exponents first. So anything that's in front, I bring it around and make it an exponent. Then I start combining left to right. So I start with the first two and I combine. If I'm adding, that means I'm multiplying. If I'm subtracting, that means I'm dividing. So these first two would be log base 3 of, and if you did this all at one time, it's okay. I just want to show you kind of my thought process. And then I can multiply together. So what's 4y times 7? 28. That's the answer. One more condensing, and let's see if you get this one, then we'll move on to expanding. She asked how much harder it was going to get. This is about as hard as the condensing is going to get. Expanding, I think. Yeah. What is 16 to the 1/4? 2. That's right.
So 36 divided by 2 is 18. And 18 times 3 is 54, Mr. McGee. Oh, right. Yeah. Oh,
2 was 36 divided by 2.
18 times 3, 54.
Yeah.
That was doing all that, and I was doing it in my head. I got it wrong. All right, do one more. One more.
One more?
It says brother what?
Brother, oh. Okay, Grayson.
That 9. Wait, 27 to the.
Log, case log 2. I'm leaving.
And I don't know where.
I'm leaving. It's just 2 and 3. It's just 2 plus 3 minus 3.
So it doesn't matter. Some of you are doing the third root of 8 and the third root. You okay? Wow. The third root of 8 and the third root of 27. Some of you are multiplying 8 and 27 and then doing the third root. Either one of those ways is correct. Remember, as long as you are doing legal rules each time, it's okay. The order, as long as you, huh? Yes, yes. So this ends up being, this can go to both because I can distribute that 1 through. I think that's a little easier. And look, actually, you could say that those cancel. Or you can say 6 divided by 3. Well, we haven't expanded yet. I'm almost done though.
But I was helping You're calling Brett Moore.
Somebody asked for another example.
Here and there, he might
5.
His interception is really high.
I don't know. Is it? Which is what? That condenses down to something else. Well, not even, you just evaluate it. What does that equal?
Why would are we expanding this or condensing?
I thought you said it's log base 6 of 36. What's log base 6 of 36 equal? All right, so here's what I do on this one. I'd say I would not take the 1/2 to both of these because they're not perfect squares. 45 divided by 5 would be 9. Yes. The square root of 9 is, of course, 3. Which would be log base 6 of 36, which we know equals 2. Just 2. Because 6 to what power gives you 36? 2. All right, let's do some expansion. Square root, because this is a 1/2 exponent. All right. Expand. It's still good. That's a 9. A to the 9th over B.
9 log 4.
Guys.
9 log 4A minus 9 log 4B.
The 9's only hooked to the A.
Okay, so 9 log 4A. A log 4B.
Really?
Wait, what?
All right, look. Shh. Don't take the exponent first here because in this case, the exponent is only hooked to the A. Okay, this is not the same as this. If you put the 9 in front of everything now, it'd be going to all of it, right? I only want it with the A, so I'm going to do log base 4 of A to the 9th minus, this is where I go in the opposite order that I was going before whenever I was condensing, okay? And then I could bring that 9 around. So there's an easy one to start you out with. That was not easy? Let's do another.
Is that some of that calculus? Is that all from today?
Y'all, come sit down if y'all can't shut up. Okay, please.
Oh, Grayson. Oh.
Come on.
Mike Tyson versus Jake Paul right now. Grayson, be Mike Tyson.
No, I'm not. I'm 59. Maybe I just went for the younger one.
Grayson, be Mike Tyson and Woody Ward.
Expand. Y'all are getting squirrely. Older than your mom? The 4 is only hooked to the Z, that's right.
Log 6x plus log 6y plus 4 log 6.
Yes.
I mean Z. No.
Thank you. I did.
4.
All right, let's see how good you are.
So Finley, you're good at condensing. I'm good at expanding.
This thing, that's
We didn't practice this at all. Does that have to square something?
Not square.
Square root. Get the square.
Yes. Say it again, Finley.
1/2. 7. Or 3.
Now can you do it?
3 log.
I'm gonna pull the 1/2 in front first. The square root. Because the 1/2's going to everything. So that whenever I split this up, because this is going to this whole piece right here, right? So now it's 1/2 times, whenever I split this up, I have to make sure that the 1/2 still goes with both of these pieces. You see what I'm saying? So if you didn't put the parentheses there, you would have to have this. Yes, you could do it this way, or either one of those would work. This is distributed through, this one's not. But either one's fine. Shut up. You ready? I'm going to pass this around. I'll do a couple more examples for those of you who need them.